where x is a vector in Rn. So it's going to be what? X square. So it's going to be this x1 square plus up to xn square. So I'm choosing this f, and for this f I'm applying the Dynkin formula. So what does the Dynkin formula says? That expectation of x tau,
conditional expectation.
you know, if you start from conditional expectation, but if you start from what? Let's call it conditional expectation, but you know, you also, if you have that formula for conditional expectation, you also have the formula for expectation actually, because expectation is conditional expectation, because expectation is what? So the expectation is the conditional expectation given omega actually. So in other words, you also have a formula for
only expectation.
Only expectation as well. Okay. So it's going to be f of x plus expectation of integral of 0 to t of what?
Operator.
Of a f operated onto xs and ds. ठीक है? यही होगा? 0 to top, so we'll have 0 to top. So what would be a in this case? So what would be a in this case?
And you have the process.
So you need to okay. So for a, you have to think from this perspective actually. Okay? So the dxt is going to be
dwt.
only
B is 0.
So what are a's actually?
B is 0.
B is 0.
And then
All these are ones actually.
Yes.
And this will only exist when I and j are equal actually. Because for others it would be all 0. So it's really a Laplace operator. It's really a Laplace operator. नहीं है समझ? So dxt is dwt. If you compare this with your general Ito lemma, Ito process actually, the first Ito process that we wrote. Okay? What was that? याद है? dxt equal to b of xt dt plus sigma of xt dwt. अब मुझे बताएं क्या होना चाहिए? So b's must be 0. All b's must be 0. And all sigmas must be 1 actually. ठीक है? So in this formula, if you're gonna put all b's 0, so this will go away. All sigmas are 1. So which terms are going to survive? Only those terms are going to survive when these i's and j's are equal actually. ठीक है? So this is really going to be Laplace operator.
We ignore 1 upon 2.
1/2 d होगा. Yes. 1/2 d होगा. ठीक है? So what would be expectation of f of x tau? Handy? Okay.
Back with the a side.
Expectation of tau is finite, f of x tau. F of x tau is going to be, so the f of x tau is going to be the norm of x tau square. Norm of x tau square. But the norm of x tau square is really r square. होगा? Think about it. So if I put x tau square, so it's going to be norm of x tau square. So the norm of x tau square is really what? It's like when this process hits this, what do you call, radius. So what is the value of x tau, okay, when it hits the radius actually? So it will be r actually. X at tau, okay, is going to be equal to r. So this must be r square actually. Isn't it? Equal to how about f of x? So for f of x, it says that it's maybe a little difference from the origin actually. It's a little difference from the origin. Okay? And this r is bigger than this absolute of a. So it's a little difference from the origin. So it started deflecting. So it covered some distance. Let's call this distance, what do you call a? Okay? And you are interested in finding its value when it happens actually. So this, for this it says a r square, and this, for this it says a square. And what would be the expectation of this actually? Del fx. So del fx is going to be, so you have to take f of x and compute its, so f of x क्या है? So it's leading magnitude of x
Square.
ठीक है? And I want to compute its what do you call second order derivative, for example, with respect to first. So it's gonna be what? So I have this expression. So differentiating it with respect to what do you call x1 2 times is going to give me 2 actually. So del f of x is really going to be 2n. Would you agree? So it's going to be 2n. So this expectation is the integral of tau to n and ds actually. Okay? Where n is a fixed number. So what would be the outcome? The outcome is going to be
n tau.
huh? So it's going to be n tau. But expectation tau पर तो operate होगी. Tau is a, so it's going to be n tau, but you need to apply expectation of n tau. So it's going to be r square.
We need expectation of tau, right?
Yes, a square plus n outside and expectation of tau. So this, it says this actually, the expectation of tau is really r square minus a square over n actually.
Sir, n क्या है?
The number
n
is
क्या n is the dimension of the Brownian motion. How many terms you have in a Brownian motion actually. ठीक है? So in other words, if I have a one-dimensional Brownian motion, in other words n is 1, and imagine I started my journey from origin. In other words, a equal to 0, then my expected time to leave the single Brownian motion is really r square. Okay? So this a is representing that, okay, you have started your motion from some fixed point a, and then you are kind of moving ahead actually. Huh?
N1.
And one.
N1
So once आप देखो ना भाई, यहाँ पर you have an n-dimensional Brownian motion. So I'm saying that take one-dimensional Brownian motion and assume that it starts from 0. And what is the time that is going to hit or leave the radius r? This is going to be expectation of tau is simply equal to r square. ठीक है? Frankly speaking, I just wanted to do this formula because I would like to apply this formula to some, what do you call, practical thing in our next class. ठीक है? Next class में ज़रूर आइएगा. We'll try to do only applications, no theory, and we'll see the different expectations actually there. ठीक है? You will see some stochastic circuits actually. So the circuits in which the current is flowing, but stochastically, a photon that leaves the sun and try to reach, for example, the earth, how much time it's going to take. Okay. Cholesterol and different kind of examples that we're going to maybe see in the next class. ठीक है? एक मजे की चीज जो कि आप देख सकते हैं यहाँ पर कैसे the abstract things are giving you interesting answers to the problem. ठीक है? ये मैं अपलोड कर दूँ.